Hi everybody, I just wanted to go through the Level 3 Maths lesson plan for this week and next week with you. If you've done all of the work on exponents and BIDMAS and order of operations and all of that stuff that I've sent on previously, then you'll be ready to move on to this lesson plan. If you haven't done that stuff, do it first, okay, because it's important that you understand all of that before you move on to number systems. Okay, the first thing that I have there is a quick quiz. I sent that to you on email as well, so it's here, it's this document. It does kind of concentrate on exponents and fractions, which is what we've been doing lately. There are a few other bits and pieces in there as well, but you can have a go at that and see how you get on. You can just write the answers out, in your copy or in a Word document if you want. You don't have to edit this document, but if you could do it and send it back to me, or send photos of it back to me, that would be great. Okay, so that's the quiz. That's just to see how you're getting on, and then back to the lesson plan. So what I want to move on to is number systems. Okay, and you'll ask what are number systems, so we'll go and talk about that in a minute. Okay, we have been spending a lot of time on exponents lately, and the reason for this is that you need to understand exponents before you're able to understand number systems and number bases. So you'll hear me talking about number bases quite a bit. And this website here gives a nice short history of the development of numbers. Have a read of it and then come back to the lesson plan. Let me just click to it so you can make sure that you're in the right place when you go into it. And it's numbers, systems and bases, okay? And what I want you to do really is just skip the first bit there, okay? So really what I want you to do is start here at way back when, okay? And read through this this page until you get to, where are we? Until you get to here anyway, considering other bases, okay? So this will be new to you. Just have a quick glance through this little bit and then you can stop here. Okay, we might come back to this later on when we're talking about hexadecimal, but for now just go as far as there. Alright, so that's that. So have a read through that and then come back. Okay, so having read through that article, you'll know that we're used to dealing with the decimal number system, or what we call the base 10 system. Okay, and basically what that means is in decimal we tick over to the next column when we get as far as 10. So we start at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We're not allowed to have 10 in our ones column, if you like, to tick over into the tens column to accommodate the number 10. Okay, and it's the exact same thing that we're always talking about with our place value chart. Okay, well, I think I have some of it down below, but it's the same thing. You get to 9, you can't go to 10 in that same column, you tick over to the next column. Okay. But there are lots of other number systems, okay, and we actually use some of them regularly. It mentioned this one in the article that you've just read, but with that time, we have 60 seconds in a minute, and we have 60 minutes in an hour, or 1 hour, okay, so that's the base 60 number system, okay. We start at 0, go as far as 59, and when we get to 60, actually we tick over from seconds to minutes or from minutes to hours, okay. And you'll notice with a lot of our, probably all of our number systems, we start at 0. 0 is very important, so don't forget about it, okay? And then after we've done the seconds and the minutes, we move to a base 24 system to manage the hours in the day. Okay, so we take over when we get to 24. We don't go, we go from 0 to 23, and then when we get into the 24th hour, well then we're into the next day, okay? If you think of your digital alarm clock, there's a good example. So after the seconds, these ones here get to 59, the seconds go back to 0, but the minutes will have gone up to 31. And after the minutes here get to 59, they'll go back to 0, but the hour here will have moved to 11. Okay? And when the hours get to 23, they go back to 0, but the day or the date has gone up by 1. Okay? And then, of course, you have the months, which have different numbers of days, so our number bases get all confused, so don't worry about that. But it's just an example of where we don't just count in tens, which is what we're used to, okay? What have we got here? Okay, sorry. As usual, this is flying down too far. Okay, In computing, some very important number bases are binary. You will hear binary used in everyday language. Some people will talk about it's a binary decision. It's a yes or no, okay? There's no grey, no in between, yes or no. That's binary. You can only have two states, on or off, or 1 and 0 as it happens to be in base 2. We'll talk about that later on. Octal, which is base 8, and hexadecimal, base 16. Don't get too freaked out about this. We'll go through them slowly and you hopefully understand them, okay, by the time we're finished with it. So in simple terms for binary, we take over when we get to 2. Now bear in mind, we start at 0, okay, so we have a 0 and a 1. We take over when we get to 2, because we're not allowed to have anything but a 0 and a 1 in any column, okay, just like we're not only allowed to have 0 through to 9 in our decimal system. In binary, we can have a 0 or a 1, and if it's more than that, off we go into our next column, okay. And for octal, we take over when we get to 8, and for hexadecimal, we take over when we get to 16, okay. And if we look at our decimal place value chart, which I am always banging on about, you can ignore the decimal point in the pink bit, okay. We're just going to talk about the ones, the tens, hundreds, thousands, and so on, okay. And what I've done here, which hopefully you'll recognise from having worked on the exponents, is I've put it into base 10 language, okay. So the ones are 10 to the power of 0. Now if you did the lesson on exponents to the 0 power, you'll know that any number to the exponent 0 is a 1, okay. You don't need to go into the theory of that, guys. It's kind of a theoretical thing that from maths that we know, but any number to the power of 0 is always a 1. So there's our ones column. 10 to the power of 1 is just 10. So there's our tens column. If you remember 10 to the power of 2, that's 10 by 10. That is 100. So there's a hundreds column. 10 to the power of 3, 10 by 10 by 10, 1,000, thousands column, and so on. Okay, so hopefully you are seeing the link between what we call in our everyday language the different columns of our face value chart in the decimal system and how they relate to exponents for the base 10 system. Okay, here's base 10, here's our exponent. All right, so try it. Okay, that's what we've been talking about here. 10 to the 0 is 1. Remember the 0 exponent from Khan Academy, because he explains it every bit as well as I ever could and better. 10 to the 1 is 1, 10 to the 2 is 10 by 10, and so on. So this is just a written form of what I've just said a minute ago, okay? And you can reference that if you want to go back and remind yourself. Now, this is also a good website to explain the 0 power theory if you want to have a look at it, but don't worry about it. I just found it the other day and I thought it was good, so I said I'd make a note of it, okay? I'm going to come back to you in a minute and we'll start on binary numbers, okay? Just need to take a quick break here.